In this video, we will be reviewing vector addition using components. The process of breaking down a vector into components that are parallel to the axes is called decomposition. We will be working in the xy coordinate system for this example to make our vector calculation much easier than it would be using graphical tip-to-tail addition. Keep in mind that some problems it is more convenient to tilt the axes, such as when finding the net force of an object on a ramp, but the idea remains the same. This approach is helpful as it's very easy to add parallel vectors together. So to begin this example, we must decompose each vector into its x and y components. Notation-wise, we need to be mindful of a few things. We will indicate a vector component with a vector hat. When discussing just a component, we refer to it without a vector hat. The component consists of three things: the magnitude, the unit of measurement, in our case meters, and a plus or minus sign that indicates where the vector component is pointing, toward the positive end or the negative end of the axis. I and j are the standard unit vectors. To organize your work, you may choose to use a table like the one I have here. We'll notice that vector A lies on the x-axis, so it does not have a vertical component. So AY is just going to be 0 meters. Since the vector is pointing in the positive x direction, the x component of A is going to be positive 2 meters. We will be using trigonometric ratios to complete the rest of this table. As we can see, we have some right angle triangles. Looking at vector B, we notice that the x component is pointing in the negative x direction. So in our table, this will be a negative component, and the magnitude of this is obtained through noticing that the x component is adjacent to the angle 37. And we also know the hypotenuse is 5 meters. So the trigonometric ratio that has adjacent and hypotenuse would be cos theta. So we have cos 37 degrees is equal to our component bx over 5 meters. Solving for bx, we get 5 times cos 37 degrees. So let's pop that in our table. Turning our attention to the component by is the opposite side from the angle 37. So we'll be dealing with our trigonometric ratio of sine theta. So here, sine 37 degrees is going to be equal to by over 5. And once again, isolating, we get that by is going to be 5 sine 37 degrees. And noticing that the vector component by is in the positive y direction, we'll place a positive sign in front of our by component to indicate that. I encourage you to pause the video here and try breaking the next vector up. So the components of the c vector were filled in similarly to what we did for b. We'll notice that the x component has sine because the x component is opposite to the angle 18 degrees. So really take a look at your picture and don't always assume that the x component has cos in it. Now we're ready to go ahead and add all of our x components together and add all of our y components together to get the x and y component of our resultant vector. It is best to save rounding until the final step of your calculation. For ease of reading, I wrote down 3 decimal places, but keep the values stored in your calculator until you obtain your final result. So we could essentially stop the problem there as we have solved for our resultant vector, but we're actually going to write it in an alternate form. We're going to write our vector with the magnitude and the angle from the x-axis. So in order to do that, we're going to use Pythagorean Theorem and the tangent function. First, we will use Pythagorean Theorem to determine the length of the resultant vector. And here we obtain a magnitude of about 1 meter. Since the angle used to define direction is typically positive and between 0 and 90 degrees, we can use the absolute value of the ry and the rx components. You can see on the picture there we've drawn in the x and y vector components that make up our resultant vector. So putting this together, we get that our r vector is 1 meter and it's 46 degrees counterclockwise from the negative x-axis.